What is Faraday's law? So when a conductor is placed in a magnetic field and that magnetic field changes, an EMF is generated. And if that conductor is a loop, it will induce also a current. So Faraday's law basically states that the magnitude of the EMF that is generated is proportional to the change of flux with respect to time. So let's examine what this means by using a model to represent our current-bearing wire loop like this. So if I place my loop within a magnetic field, which in this case is going into the screen, because flux is equal to the magnetic field strength multiplied by the area, assuming the two are parallel to each other, first I can change the area. So if I increase the area, then I generate an EMF and I induce a current, as demonstrated by the arrows. Another way I could do this is I can change the strength of the magnetic field. So, for example, if I increase the magnetic field strength, I generate an EMF and thus generate an induced current, as shown. Now, of course, in both cases, the EMF is proportional to the rate at which the variables change. But there is another way I can also generate an EMF, and that is by rotating my loop of wire. Now, since the area of the magnetic field passing through the loop changes as I rotate it, then we have a rate of change of flux. Graphing it, it looks like this. But the EMF is proportional not to the flux with respect to time, but to the rate of change of flux with respect to time. So when the flux is at a maximum, the flux isn't changing much. In other words, the rate of change of flux at that time is zero, so we don't get an EMF. However, when flux is at a minimum, or zero, the rate of change of flux in fact is at a maximum, and so as a result we get a maximum EMF. And so if we graph this, we get this. But what about the negative symbol, you ask? Well, that's a reference to Lenz's law. Lenz's law in essence states that the direction of the induced EMF will be such that it opposes the change that generates it. That means our EMF graph will now look like this. Finally, what about the N? Well, I have only one loop here. If I have a coil instead, multiple loops, then each turn of that coil will increase the strength of the EMF that is generated. So the N stands for the number of turns within your coil. So that is a summary of Faraday's law. Finally, I want to acknowledge the input of Simon Crook from Crooked Science for the inspiration for this video. More information on the professional development he provides will be in the description below. My name is Paul from Physics High. Take care and bye for now.